A pleasant day, STEM learners. This is Sir Peter, your pre-calculus teacher. So now, we are now on week number 3, the domain, the range, and graph of circular functions. So at this end of this video lesson, you should be able to illustrate the domain and the range and examine the graph of the 6 circular functions that we have discussed in week number 2. When you hear the word periodic, what comes out of your mind? So a periodic is a phenomena which are found in real-life situations. One perfect example is the human heartbeat, which can be graphed through the electrocardiogram or what we know as the ECG. So this is also known as the lifeline of a human being. So as you observe, the flood current also follows a certain periodic phenomena, which is the low tide and the high tide. So every day, the water level changes periodically. Then look at this comet surrounding a certain heavenly body. So it also follows a certain periodic rotation. And of course, in astronomy, we can also observe the elliptical orbits surrounding the sun, which comprises the different heavenly bodies that rotates or revolves around the circle, the sun, which is the center of the solar system. So periodic functions are functions whose values are cyclical or repetitive. So we can observe that in real life situations. So the values of periodic functions repeat after a certain interval. So observe this graph on the right. As you observe, its period is 2. So every 2 periods, the cycle continues, okay, after 2 periods. So this only means that the pattern tends to repeat after an interval of 2 units. And again, that 2 units is what we refer to as the period. Now, how do we determine the domain, the range, and the graph of circular functions? So we'll talk about the sine function, cosine function, cosecant function, secant function, tangent function, and number 6, we have the cotangent function. Let's start with the sine function. So the given function is y is equal to sine x. Using your calculators, let us try to find sine 0. So sine 0 is equivalent, of course, to 0. Sine 30 degrees or pi over 6 is 1/2 or 0.5 in decimal. Sine 45 degrees or pi over 4 is the square root of 2 over 2, which is approximately 0.71. Sine 60 degrees or sine pi over 3 radians is the square root of 3 over 2, or it is approximately 0.87 in decimal form. And the rest will just repeatedly have the same values. Look at that one, the sine functions. It repeats periodically with these certain values. And their signs will depend on which quadrant does the angle belongs. So when we graph those points on the table of values, this is how it would look like. And when we periodically repeat it every 360 degrees, and then the next rotations for we have 2 pi, which is 360, and then 4 pi, which is 720 degrees. And then on the other side also, we have the negative angles. It will just periodically show this graph. So let's recall. So for y is equal to sine x, this is how the table of values look like, and the graph looks like. Observe that the domain is continuous across the x-axis. So the domain is up to negative infinity to positive infinity. So it is endless across the x-axis. For the range, observe that the values does not exceed 1 across the y-axis and does not exceed -1. That's why the range must always be -1, between -1 and 1 only. So it is very impossible to get the sine of an angle which is 1 point something or -1 point something. So it must not exceed the values -1 and 1. So therefore, the maximum value that you could get is 1 and the minimum value that you could get is -1. Notice that the period is 2 pi. So every 360 degrees, there is a periodic repetition of this graph. Let's have number 2, the cosine function. So it is represented by y is equal to cosine x. Substituting the values, we have y is equal to cosine 0. The answer is 1. Y is equal to cosine 30 degrees or cosine pi over 6 radians. The answer is the square root of 3 over 2. Cosine 45 degrees or cosine pi over 4 radians is equivalent to the square root of 2 over 2. And we have cosine 60 degrees or cosine pi over 3 radians is equivalent to 1/2. We all know that. And of course, there will be periodic repetitions across the 4 quadrants, and their signs will depend either a positive or a negative value for the y will depend on which quadrant they belong. But as you observe, the values just repeats. So when we graph the cosine function, this is how it would look like. Look at that one. So let us try to observe and compare the table of values from its graph. The domain is the same with the sine function. It is infinite, no? On both directions across the x-axis. So our domain is negative infinity, positive infinity. For the range, we have same, -1 and 1. So therefore, the maximum value is 1 and the minimum value is 1. Notice that it does not exceed on these values. But how do we observe the periodic rotation? Again, the periodic repetition or the cycle repeats after 2 pi. Okay, so after this one, it will also repeat using the same pattern until the next revolution, which is 720 degrees or 4 pi. Same thing happened for a negative angle. Now let us consider the third function, which is y is equal to cosecant x. So we have y is equal to cosecant x. To get that value, that is 1 over sine x. So that is undefined. Y is equal to cosecant 30 degrees. The answer is 2. Y is equal to cosecant 45 degrees. The answer is the square root of 2. And y is equal to cosecant 60 degrees or pi over 3 radians is equivalent to 2 the square root of 3 over 3. And of course, it will just have periodic rotations again and periodic values based from how we define. So let Q be the undefined. Now, this is how the graph looks like. So it seems that we have the red one is our cosecant function, and compared to its reciprocal, which is the sine function. Notice that the cosecant function seems to have asymptotic parabola upward and downward, in which one of the vertex coincides with the vertices of the sine function as well. So as you observe, both sides of the parabola are what? They are asymptotic to both sides. And which x values do they coincide? Let us compare. Observe that the domain are all the set of real numbers, only that sine x cannot be equal to 0 because it will be undefined if it becomes 0. Okay, so this is the restriction. As you observe, it is also asymptotic to x equals 0, which is the y-axis. So notice also that x should all be real numbers, only that x also should not be equal to k pi. So every 180 degrees, this one, 180, 360, the graph also is asymptotic to that part. So they cannot be equal to that. And only integers. So we have 3 pi, 4 pi, 5 pi, and so on, no, will be restrictions for the real numbers of the domain x. For the range, as you observe that it starts from the value 1 to positive infinity. So that is your upper boundary. For the lower boundary, we have -1, all the points here, -1, then to negative infinity. So the graph only exists on these parts, no? All the real numbers except 0 pi, pi, 2 pi, 3 pi, and so on. And for the range, we have -1 to negative infinity, and then 1 to positive infinity. The maximum value is none because it is infinity, and the minimum value is also none because of the infinity sign. So again, every 2 pi, there is a periodic rotation of the parabola, which opens upward, downward, then upward, downward again. So that is the period. Now let's talk about number 4. Y is equal to secant x. So we have, let's start with y is equal to secant x, negative pi over 2, which is negative 90 degrees. So that is undefined. Negative 60 degrees, that is 2. Negative 45, the square root of 2. Negative 30 degrees, that is 2 the square root of 3 over 2. Then it will also have periodic values across this table of values. So that is how it would look like. So comparing the table of values in the graph, its domain would now be, so x is the set of real numbers, except that cosine function should not be equal to 0. Because when it's equal to 0, then it will be undefined. And notice that k should be an odd integer. So it can only be 135. So it could be pi over 2, 3 pi over 2, 5 pi over 2, meaning they are asymptotic on those parts. So they should not be equal to the 90 degrees, 270 degrees, 450 degrees, and so on. So you repeatedly add 180 every k pi over 2. So those are not included because the graph becomes asymptotic on those parts. So they will never touch those graphs. For the range, we have same with cosecant. We have negative infinity, -1, union 1, positive infinity. So as you observe, all of the range starts from 1 to positive infinity and -1 to negative infinity. So the red graph represents the secant function, while this one represents its reciprocal, the black part, which is the cosine function. Maximum value is none, and minimum value is none because of the infinity sign. And again, the periods of an upward and a downward direction starts every 2 pi. Let's have number 5, the tangent function. So x, if we have y is equal to tangent -90, we have undefined. -60, we have negative the square root of 3. -45 degrees is -1. And negative pi over 6 is negative square root of 3 over 3. And again, it will repeat on those values. Comparing the graph of the tangent function. Again, there are somehow asymptotes here that you could observe in the graph. The domain is all the set of real numbers, except that cosine will not be equal to 0. Why? Because we know that the tangent function is equal to sine function over the cosine function. So there is a restriction that x should not be equal to 0 because it will be undefined on that part of the denominator. As well as k should be an odd integer. So every 90 to 70 for 50 degrees periods, they should not be equal to it because on these parts of the graph, they will be asymptotic. Look at the asymptotes. Okay? Even if you extend that one, they will not meet on those parts, which are the odd integers of k pi over 2. So 90 to 70, and then we have pi over 2, and so on. 7 pi over 2. For as long as they are odd integers, all of them will be asymptotes on that part of the graph. As you observe, the range is continuous upward and downward. So the range is negative infinity to positive infinity. Of course, the maximum value will be none and the minimum value will be none. Observe that the period now repeats every 180 degrees for every pi regions. Okay, so unlike the other functions, they periodically repeat every 2 pi or 360 degrees. But in the case of a tangent function, it only repeats every 180 degrees or every pi. So it has a different period. And lastly, we have the reciprocal of tangent. Y is equal to cotangent x. The same. It will have those values. But look at the reciprocal. It's the opposite side of the tangent function. The domain is, since the cotangent function is equal to the sine, the cosine function over the sine function, it is restricted on sine x, okay? Should not be equal to 0 because that will be undefined in the denominator. And then we follow the periodic repetitions of k should be an integer. So we have k pi, it could be pi, it could be 2 pi, and so on, 3 pi, for as long as it is an integer, or 4 pi. Notice that every pi, 2 pi, they can never be equal to that value of x because the graph are asymptotic on those parts. So that is every 180, 60, 540, 720 degrees, and so on. They can never be equal to x. But all the rest of the real numbers could be equal to that value of x, or the domain. For the range, as you observe, the range is again negative infinity and positive infinity because the graph is continuous across the y-axis, upward and then downward. So it is negative infinity, positive infinity. And if we have infinities, then the maximum and the minimum values will be none. Notice again that the period repeats every after 180 degrees or pi regions. So I hope you learned something from the graphs of the 6 circular functions. So we are now done with week number 3. For the next video lesson, we will talk about amplitude and the period of circular functions. Again, this is Sir Peter, your pre-calculus teacher.